In this video, we're going to discuss annuities. The basic idea behind an annuity is that you're making periodic payments into an account that is earning compound interest. When we use the term annuity, we are describing a very generic concept. In the investment world, there is a specific financial vehicle called an annuity, and we are not referring to those specific investments only. We are referring to any investment where you make periodic payments, whether they be into a bank account, into a mutual fund, or into an annuity. Let's look at an example of an ordinary annuity. An ordinary annuity is an annuity where you make your payments at the end of a period. So for example, suppose we are making payments of $500 a month for 4 months, and they're going to earn 10% monthly. So we're going to be making these $500 payments at the end of the month. Now we can figure out the future value of this annuity, what it'll be worth at the end of the 4 months, just using our compound interest formula. For example, the first payment we make of $500 is going to be in a compound interest account earning 10% monthly for 3 months, so 3/12ths of a year. The reason it's going to be in there for 3 months is because we place it in at the end of the first month, so there are 3 more months left for it to earn interest. Then we will add to that the $500 placed at the next month. Now that $500 will also earn compound interest, but it only earns interest for 2 months. We also have the third payment, which will earn compound interest, but it'll only earn it for 1 month. And finally, we have the last payment, which is made just before the account becomes due, so it doesn't earn any interest. Now, if you add up all these numbers using your calculator, you'll find that the total future value of this account is $2,025.14. Now imagine if we wanted to make these $500 payments for 30 years, not just 4 months. This calculation would be very long and tedious. Well, it turns out that there's a formula which will allow us to find the future value of an ordinary annuity without having to do all of this work. If you look in your textbook, there's a description of the derivation of this formula, but for this video we're just going to provide the formula. The formula is that the future value of an ordinary annuity can be found by taking the payment size times 1 plus r over m raised to the m times t minus 1 all over r over m. In this formula, payment is times the entire formula, or the entire fraction here, so sometimes it's good to consider the fact that you could put these square brackets to remind you that it's payment times this entire fraction, not just payment times the first piece on the numerator of the fraction. Now, if we wanted to, we could compute the future value of the previous example. It's $500 times 1 plus r over m raised to the m times t. In this example, t is 4/12ths of a year, minus 1 all over r over m. If you work this out in your calculator and you round it to the nearest penny, you'll find that you get $2,025.14. Now in this example, we paid $500 4 times, which is $2,000. But in our account we made $2,025.14, so we earned $25.14 in interest. Now that doesn't seem like a lot, so let's see if this is actually worth doing. Can we really make money by investing in an annuity payment? Suppose that we place $100 a month and it's going to earn 8% interest, and suppose we're going to leave it in there for 30 years and it's going to earn 8% monthly. Okay, well, if we work out how much money we're actually going to pay into this account, we're going to pay $100 12 times a year for 30 years. It's $36,000. The future value of this account can be found by working this formula out. 100 times 1 plus r over m raised to the m times t minus 1 all over r over m. And if you work this out on your calculator, you'll find that it's worth approximately, rounding to the nearest penny, $149,035.94. Now that's quite a bit of a difference. An annuity due is an annuity where you make your payments at the beginning of the period. Now if you think of our original example of an annuity, if we made our payments at the beginning, the only change would be in these numbers, as well as adding one compounding period to this $500. So the first 500 would have 4 months, the second 500 would have 3 months, the third 500 would have 2 months, and the last 500 would have 1 month. Basically, all of these numbers would gain one more compounding period. So if we took, for example, the last problem we did, and we wanted to know how much would our future value be if it was an annuity due instead of an ordinary annuity. For an annuity due, we could simply take the future value of our ordinary annuity and give it one more compounding period. So just for 1 month, so 12 times 1/12. And this would give us the future value of an annuity due, an annuity where the payments were made at the beginning of the month. Again, the idea is all of that money, every single payment gets one more compounding period. So that's all we're doing is multiplying by one more compounding period. And if you look at the formula in the textbook, it looks just like the future value of an ordinary annuity, but at the end we multiply by 1 plus r over m. Because the 12 times 1/12 simply multiplies out to 1. Let's look at another example of using the annuity formula. Suppose we need $50,000 in 10 years, and suppose we're going to make weekly payments into an account earning 5% interest compounded weekly. How big must the payments be in order to reach the $50,000 in 10 years? And let's assume that this is going to be an ordinary annuity. So we know the future value of this annuity. It's $50,000. We're solving for payment. And we know the interest is 5%. It's weekly, so it's 52 for M. It's going to be in there for 10 years. So now we need to solve for payment. To solve for payment, we can divide both sides by the entire fraction. Again, as we've done before, when we divide by a fraction, you remember to flip and multiply. You don't have to, but it sure does save you in calculator work and can avoid some common calculator errors. So we have 0.05 over 52 divided by 1 plus r over m raised to the m times t minus 1, all of this times 50,000. When you multiply a fraction times a whole number, remember the 50,000 is over 1, so the 50,000 is multiplied on the numerator. The 1 would be multiplied in the denominator. This equals our payment. And if you type all of this into your calculator very carefully, you'll find that this is going to be a payment size of approximately, rounding to the nearest penny, $74.16. When typing this into your calculator, make sure that you take care of the implied parentheses. There's a set of implied parentheses for the denominator, and there are a set of implied parentheses for the numerator. Technically those aren't necessary, but it doesn't hurt to type them in. They're not necessary in this case because everything in the numerator is multiplication and division. There is no addition or subtraction. And there are some implied parentheses around this exponent. So make sure you get those implied parentheses typed in if you want to get the correct answer. The last thing we'd like to look at is the idea of the present value of an annuity. And we'll use this last example to do this. The present value of an annuity is the lump sum of money I would need in my hands right now, so that if I had a compound interest account earning the same interest rate with the same compounding period as the annuity, I could generate the same future value as my payments would make. For example, in this last example, if we paid $74.16 a week every week for the next 10 years, we would generate the $50,000. To find the present value of this annuity, we would have to solve the following problem. We want the $50,000, but we want to generate it just by putting some lump sum of money in a compound interest account at 5% weekly for the next 10 years. And if you solve this for P, you'll find in this example that P is $30,333.82. So that would be the present value of this annuity. So another way to think about this is if somebody told you they were going to pay you $74.16 every week for the next 10 years. You would be willing to, if you had a 5% investment that you were placing this in, you'd be willing to exchange that annuity for $30,333.82 right now, because if you put that money in the same account, you would generate the same $50,000 in 10 years.